Hello students, in the today's class we are going to talk about the Cannizaro reaction. The Cannizaro reaction is also known as mutual oxidation reduction reaction. This is also called as disproportionation reaction. What is called disproportionation? If we take two molecules of benzaldehyde, one will be oxidized and other will be reduced. So simultaneously both oxidation reduction takes place and hence it is called disproportionation reaction. And there is a condition, either an aliphatic aldehyde or aromatic aldehyde. It should not have any alpha hydrogen. It is quite opposite to our aldol condensation. In the aldol condensation we have discussed that there is a need of at least one alpha hydrogen. But here there should not be any alpha hydrogen atom. That's a major difference in between the Cannizaro and aldol condensation. You see, the aldehyde, benzaldehyde, C6H5CHO, this is a structural formula where there is a carbon bonded with CHO. This carbon is alpha carbon, but there is no hydrogen and hence it can undergo Cannizaro reaction. Formaldehyde, the functional group is CHO, but there is no alpha carbon. When there is no alpha carbon, definitely there is no alpha hydrogen. So these two aldehydes can answer for Cannizaro reaction. We are going to explain the entire Cannizaro reaction with the help of mechanism. So without the reaction, directly I can explain the mechanism. Step 1, where we will take the benzaldehyde C6H5 C double bond OH. The reagent is sodium hydroxide NaOH. That would be dissociated to form Na plus and OH minus. We know that OH minus can behave like a nucleophile. So OH minus is attacking this carbon. The nearby bond is breaking up and oxygen can carry minus. Execute the change and find a product. This is the product obtained, C6H5 CH. It becomes O minus and here I can write OH. This is the first step we should take. After this step, in the second step, step number 2, write this substance in the reactant side. C6H5 CH O minus and OH. Now this is to be treated with the second molecule of benzaldehyde. Then what happens? There is a chance of transformation of this proton to the carbon atom. See the movement of electron. Hydrogen is moving from this carbon to this particular carbon atom, and it is taking up the pair of electron. Usually hydrogens are transferred as proton H plus, but here the hydrogen is transferred as H minus, and which makes a bond with this carbon atom. Once a new bond is formed in between the carbon and carbon, the hydrogen and carbon atom, and we know the valency of carbon, it is equal to 4. Once when you detach this hydrogen, there is a need of another bond and hence subsequently this electron pair is moving towards the side. So there will be double bond in between carbon and oxygen. Likewise, when there is an initiation of bond in between carbon and hydrogen, this bond is opened and oxygen is carrying minus. Execute this change and find a product. We can have C6H5 C double bond OH. It becomes benzoic acid. And what about the other one? It becomes C6H5 CHH, newly added hydrogen. This carbon is bonded with the hydrogen. The bond breaks up and oxygen is carrying minus. So at the end of second step, we can have these two products. Now try to write those two products in the reactant side in the last step, step 3, where we can write the substances benzoic acid C6H5 C double bond OH plus the substance obtained above, C6H5, CHH, and it is O minus. Then what happens? In order to neutralize this O minus, the O minus provides electron to this hydrogen. So this O minus is getting protonated with the help of this replaceable hydrogen. And the hydrogen is leaving as H plus. The bonded electrons are moving towards the oxygen, and hence oxygen carries minus. So see the product side, C6H5, double bond O, it becomes O minus, plus C6H5, here it is CHH, OH. So one of the substance is benzoate. This is the benzoate what we are obtaining. As we were started with the sodium hydroxide, the Na can be attached with this at the end. So the final product might be sodium benzoate, one of the compound. Other one is an aromatic alcohol. The name of the alcohol is benzyl alcohol. So you can understand that one of the benzaldehyde, it undergoes oxidation. At the end, we are getting the oxidized carboxylic acid, benzoic acid salt, sodium benzoate. And other benzaldehyde is getting reduced to form benzyl alcohol. Thus it is called self-oxidation reduction, also known as disproportionation reaction. So this is the explanation for Cannizaro reaction, aldehydes without alpha hydrogen. The best example is benzaldehyde. Benzaldehyde is not containing the alpha hydrogen, and hence it is answering for this. At a glance, in the first track I am telling C6H5C double bond OH. The OH is attacking the carbon, the nearby bond breaks up, and we are getting this substance. This is to be given in the reactant side. Take a first molecule of benzaldehyde, transfer this hydrogen as H minus, it is bonded with the carbon. Subsequently, the bond opens, oxygen is carrying minus. When you remove the hydrogen, there is a need of another bond, and hence this pair of electron is moving between the carbon and oxygen. There will be double bond in between these two. So I am getting the benzoic acid and the benzoxide. They are to be given in the reactant side. At the end, finally, from the benzoxide, to make it neutral, the electrons are available for the hydrogen. So it is getting protonated, and finally that becomes benzyl alcohol. The pair of electron is moving towards the oxygen. It carries minus. This can be neutralized by taking the sodium. So we are getting sodium benzoate. So this is about the Cannizaro reaction. Thanks for watching.